So in this side, we have a square layout of size 5 cross 5, whatever meters each. 25 equal size squares platforms of different heights are built. The heights are indicated by these numbers. Okay, so now individuals all of the same height. Oh, so people of the same height are seated on these platforms. Okay, so all of are of the same height. So okay, I understood that. Because the platform themselves have different heights, so that is relevant. So height of the individuals are not relevant anymore. Uh, we say an individual A can reach an individual B if all three following conditions are met. Okay, so it's movement among this grid, right? So individual A can reach individual B if all the three conditions are met. Okay, let's see the conditions. The first says A and B are in the same row or same column. Okay, so no movement diagonally, so it has to be either row or column wise. So something like this or something. Anyhow, I hope this is everybody can understand that. Number two says A is at a lower height than B. Okay, so A's height should be lower than, so basically the platform height. This is what I was slightly talking about while I was reading that part. So I'll mention this elaborately. So because all the individuals are of the same height, all that matters is the height of the platforms, right? Whichever is a higher platform, the person is on a higher height, something like that. So A is at a lower height than B. So something like, I mean, you can reach from 1 to 6, you can reach from 1 to 2, something like that, maybe. Yeah, so A is at a lower height than B, so this is one condition. Uh, Number three says if there is or are any individual between A and B, then the individuals must be at a height lower than that of A. Okay, so if I have an individual between A and B, so if A and B are adjacent, we don't have to worry about this point number three. If so, the examples that I took, 1 to 6 and 1 to 2 are reachable. But if there is anybody in between, then they have to be at a height lower than that of A. What it implies is I cannot go from 1 to 4 because this 2 is on a higher height. If there are individuals in between, then that must be at a lower height than that of A. So let me mark this out. So what I understand is something like this. So let's say this is the individual A and this is the individual B. Either if there is no person in between, so it's on a higher height. So this is by scale or something. So directly they can reach. So this is possible, and there is nobody in between. So let me keep that as a 0. So nobody in between. And if there is anybody in between, they all have to be on a lower height than this person, right? So they have to be lower height than this person. So this could be any number of people, and then there has to be a higher thing, because if you have to reach from A to B, the second condition says that A has to be on a lower height than B. So if all of these are lower than A and B is more than A, so B is definitely more than these people, right? So there is again no gap. So something like this, right? So let me elaborate with some example, or they might have given some example, right? So yeah, thus in the table given above, consider the individual seated at height 8 on the third row and second column. So third row and second column is this 8. He can be reached by 4 individuals. So let's not look at these examples. Let's figure that out. So the example claims that 8 can reach via 4 individuals. So which are the individuals? Obviously 7, obviously 5. See, not via 1. You cannot reach via 1 because this condition is violating. If you have to reach from 1 to 8, the 5 had to be lower than 1 in height, right? But that is not true. So you cannot reach via 1. 9 is definitely not possible. You cannot reach from 9 to 8 because that's a higher height than 8. 4 to 8 is possible. 4 to 8 is possible. Even 6 to 8 is possible. So these will be the individuals. So 6 to 8 is possible because 6 to 4, see this idea. So 6 to 4, there's a reduction and this is an increase. So I hope this left to right and right to left is not confusing. This is just an indication for me to understand later on that this kind of movement should happen. So we have, that's it. So these are the 4 individuals, this 5, this 4, this 6, and the 7. So let's look at the examples. He can be reached by the individual on his left at 7, by the 2 individuals on the right, heights 4 and 6. So these are the 2, and by the individual above at height 5. So yeah, So I have understood the set. So this is something, if you do beforehand, then you can verify it from the example that whether you have understood it properly or not. Now rows in the layouts are numbered from top to bottom and columns are numbered from left to right. Huh? Okay. So row numbers. So rows are numbered from top to bottom. So we have something like this: R1, R2, and so on, R5, top to bottom. And columns are numbered from left to right. So I'll write it on top because this is one. So columns are numbered, column 2 up to column 5. So this is a numbering of the rows and columns. Okay. So this might be effective in some question, because if the question says this column number and this row number, then that might be useful. So let's get the questions now, because this doesn't have anything more to solve, sort of a DI thing only. So let's get the question now. Okay, 25. How many individuals in this layout can be reached by just one individual? Um, wow. So I have to figure out for each and every layout here, or each and every height. Let's look at some other questions. So 26. Which of the following is true for any individual at a platform of height 1 meter in this layout? Okay. So we are just looking for those platforms which are height 1 meter, right? So let's look at the options here. First says they can be reached by all. Silly. They can never be reached. They can be reached by at least, again, silly. They can be reached by never. They cannot be reached. This is the answer. See, we already know that whichever person you have to reach, so that A and B thing, the second condition here, A is at a lower height than B. Nobody is at a lower height than one, right? So one can never be reached. This is a very simple question. So 26 is D. 27, we can find two individuals who cannot be reached by anyone in the. Okay, so this I can go option by option again. So we are looking for two individuals who cannot be reached by anyone. Okay, so last row. So let's test this out. So one is definitely one of the individuals. So this is I just put tick marks for so by last row. I'm just testing the last row, by the way. So I'll just put tick mark whichever satisfies this condition, cannot be reached by anyone. So this is the condition I'm using. 7 can be reached by 6. So this is not. 6 can be reached by 5. Cannot. 3 can be reached by 1. So 9 can be reached by anybody, right? So similar to our previous question, as 1 cannot be reached by anyone, 9 can be reached by at least anyone adjacent to it, right? Otherwise, I mean, we have to think about this condition, this third one. But then at least somebody who is adjacent to 9, there will be somebody adjacent to everybody, right? So only if there is two nines together, so that is not there in any of the layouts. I mean, any of this. So 9 can be reached by everybody. So last row is not the answer. We need two individuals, so we just have one tick. So let me take this off. So last row is incorrect. Let's look at the next option, fourth row. Okay, so fourth row is this one. Now let us do the same thing. 3 can be reached by 1, so not satisfying the condition. 9 can be reached by, again, same idea. 5 can be reached by 4. 1 cannot be reached, that is fine. But 2 can be reached by 1, so this is also out. So again, there's just one individual here. So this option is also ruled out. So we can take this off. So let me take this part off as well. C says fourth column. Okay, so fourth column is this one. Let's test this out. 4 can be reached by a lot of these, 2, 3, this 2. So this is out. 2 cannot be reached by anybody here, right? Just look at the adjacent ones first, always. So 2 cannot be reached by anyone here. So this is ruled out. 6 cannot be reached. 6 can be reached. So basically, what did I do for 2? I was just actually, sorry for that. I was just pondering on the 2 thing. 2 is actually satisfying the condition, right? I'm confused myself. 2 is, I mean, we are looking for where people cannot be reached by anyone. So 2 is actually satisfying that condition. So we should put a tick mark for that. And 6 is, 6 can be reached from this 2, from this 1, 4, 5, anything. Always says the adjacent one first. 1 we already know cannot reach. So we are already getting two people. We just need not more than two people, but three can be reached from this one. So this is violating. So yeah, so we have two people, this two and one, who cannot be reached from any one of the individuals. So fourth column. So this is easy. So we can do this quickly. Relatively easier than the first one I meant. That's question number 25. That is something to do, I believe. Okay, 28. Which of the following statements is true about this layout? Okay. Each row has an individual. We're looking for true, right? Okay. Each row has an individual who can be reached by five or more individuals. Each row. That is absolutely silly. There are many rows where we have one, right? Oh, has an individual. Okay. How do I test this? Okay. Five or more, right? So five or more cannot be on the corners. It could be in the corners. Five or more. Okay, I might have to test it. Let me leave that as of now. Let me test the next option. Each row has an individual who cannot be reached by anyone. This is incorrect because there are many rows. We were testing this in the previous question itself. There were many rows in which an individual. Uh, okay, so wow. No. This is saying each row has an individual who cannot be reached by anyone. Okay, so let's test the rows first. No, I should not put a cross here. There could be an individual who cannot be reached by anyone in each row. Let's test that out. So let's test the rows which doesn't have a one. So let's test with this row. So 7 can be reached, 8 can be reached from 5, 4 can be reached by 3, 6 can be reached by 2, and 5 can be reached by 2. So this is, yeah, now we can put a cross. So B is out. So option B cannot be the answer. Let's test the next one. C says each row has at least two individuals who can be reached by an equal number of individuals. This is too much to test. Each row, equal number of individuals. I have to test all the rows. So let's leave the C for later on. And D says all individuals at the height 9 meter can be reached by at least five individuals. Okay, 9 meter. Okay, so now this is less to test. Let's test this out. So let's test this 9 first. So this 9 can be reached from 2, can be reached from 5 because of this idea. I'm just using this idea. 5 to 2 is a drop, and then 2 to 9 is an increase. Can be reached from 8 also. See, 8 to 5 drop, 5 to 2 drop, and then 2 to 9 is an increase. So this idea is what helping me. So these three individuals can reach 9. This is also possible. 3 can reach 9, 6 can reach 9, 7 can reach 9. So this 9 is definitely satisfying this condition. Okay, let's test the other 9. Let's pick up this 9. Let's say I'm picking up with the corners and the edges because that will anyhow have less possibilities than the center one, ideally, because less adjacent squares and all. If that doesn't work, then we'll go ahead with the center ones. So what about this 9? The 6 can obviously reach. The 7 can reach, but not this 3. See, 3 to 9 is a continuous increase. We cannot have continuous increase. This can reach by 5, but not by this 3. So this 9 is reaching by only 3 individuals. So you cannot have 5 individuals for this 9. So this option is also out. So now I could take a call on A and C. I believe A should be easier to test than with C. So let's go with A, because for C, I have to figure out each and every individual. That would be something for question number 25 anyhow. 25 also have to, but then for 25 I don't need to figure out each and individual number of times they can be reached, right? I just need to find for one individual. So let's test point number A, or sorry, option number A for 28. If that is also ruled out, then C is the answer. Otherwise A we can straight away mark. So let's test A. Each row has an individual who can be reached by 5 or more individuals. Okay, let's test this out. Let's test this row first, because while I was testing this option D, I know that 9 is not satisfying this condition, because that 9 can be reached by only 3 people, and the row which has a 9 and cannot be reached by 5 individuals is not something very something which can satisfy this condition. So let's test start with this particular one. Uh, let's test 8 first because that's a higher number. 8 can be reached from this, from 5, from this 2, and from this 3, and also from this 5. Okay, so this row actually worked. So this row has one individual who can be reached by 5 or more. So let's try to find a row which has lower values. Okay, so let's try this row. This has comparatively lower values, right? Doesn't even have a 7. So first of all, the 1 cannot be reached at all. 2 can be reached only from this 1. 4 can be reached on from this 2. Okay, 4 can be reached from this 2, from this 3, from this 2, and this 6. So not 5 individuals, so only 4 individuals, right? So 4 is also not working. We need 5 or more individuals. 3 cannot be reached at all, so let's strike that off. 6 can be reached from this 1 alone. So see, this row doesn't have 5 individuals. I mean, any individual who can be reached from 5 or more. So A is A is the wrong option, so we can eliminate that too. So C is the answer, right? So each row has an individual who can be reached by 5 or more individuals. That is incorrect. So C was actually correct. Oh wow. Anyhow, so that's a nice one. Let's now solve this 25. So 25 is asking for how many individuals in this layout can be reached by one individual. So what I'm going to do is I'm going to take this part off because that is not required, and I'll just create a bit of space to work on. So I'll just remove this below, move this below. I might require this. The row numbering is not very important here. Okay, so for 25, we have how many individuals in this layout that can be reached by just one individual. So let us, so for this question, I need to redraw this. So let me do this. So I'll just quickly draw this now. Now we need to have the individuals reached by exactly one individual. So that is not 0, not even more than 1, right? So what I can quickly do is I can quickly strike out these ones and nines. That thing I can do because none of the ones will satisfy. They cannot be reached at all. And every 9 will be reached at least from the adjacent one. So nines are straight away out. So 1 and 9 we can straight away rule out. Now let us work on the remaining ones. Let's start with the higher numbers first. So let's start with 8s. Now 8, this 8 can be reached via 5, 4, 7. So this is also out. This 8 can be reached via 5, 2, 3. So this is also out. So 8s are done. Now let us look at 7s. Now this 7 can be reached only via this 3. So this 7 coincidentally actually qualifies. Okay. So this 7 is fine. Now this 7 can be reached via this 6 as well as this 1. So it can be reached from both the ends. So we can rule out this 7. So this is out. We don't have any more 7s, right? So let's test the 6s now. 6, this 6 can be reached via the 5 as well as the 3. So we can rule this out. We don't have to go ahead from that. 6, this one can be reached via this 1, also via this 2 because of that decreasing, increasing thing. And 6 is more than 2. So we can rule this out. Okay. What else? So 6s are gone. We don't have too many left, so let's now go in sequence. So what about this 2? So 2 can be reached from 1 and 1 alone. So this is satisfying. So this 2 is satisfying. The 4 can be reached from 2 and 3, so that we can rule this out. This 3 cannot be reached at all, neither from 4 nor from 8, so no need to go beyond that. This 5 can be reached via this 1, also via this 3, so we can rule this out. This 3 can be reached via this 2, so we can rule this out. This 2 cannot be reached at all. Check the adjacent ones first. So cannot be reached. This 4 can be reached via this 3, and that's it. Because you cannot reach from this 2 because continuously increasing. So this is definitely satisfying. Only one can reach 4. The 6 here can be reached via this 4 or 5, so we can rule it out. This 5 can be reached via this 2 and only this 2, right? We cannot reach from 9. So this is definitely there. Uh, that is that is one which is satisfying the condition. Now, what about this 3? This 3 can be reached only via this 1, obviously nothing else. So this is definitely in. The 5 here can be reached via this 4 and 1, so we can rule this out. The 2 here can be reached only via this 1, right? Nothing else, because you're going to reach from 5 to 2, right? Because 5 is a higher height than 2. So this is definitely there. And we're left with this 3. Now this 3 can be reached only from this 1. So this 3 also qualifies. So let's count the ticks. So we have 1, 2, 3, 4, 5, 6, 7. So we have a total of 7 individuals. So that is the set. Now let's analyze this. Okay, so this is a pure example of a DI, because DI is not only bar graphs or pie charts and stuff. The way I categorize a DI is those kind of sets where you don't have to solve anything in the set itself. I mean, a little bit of analysis might be required. This was a very small analysis, this one and that row and column numbering. So a little bit of this thing will always be there. It's cat after all. But you don't have to solve anything in the set per se. So the only thing you have to solve is for the question by question. So these kind of things are important. So let me take some time to analyze one thing about this set. First of all, in terms of difficulty level, I will definitely categorize this as a easy one, because there's not anything to do as such in this set. It's definitely an easy DI set. In terms of the ideal time that you should spend, let me put it this way. So this is the part that I'm going to explain a little bit on details. In DI sets, you have an advantage. The advantage is, because you have not spent too much time in solving the set, now you can take some decisions. The decisions are whether to solve each and every question or not. This kind of decision will not be there mostly in an LR set. There will be in certain situations, but mostly you won't have this decision in an LR set, because in an LR set you have already dedicated some time once you have chosen that set. I mean, as something that you will do in the paper, you solve in the paper. But in a DI, there is not anything to solve as such. So whatever time is going to be spent will be spent on each and individual questions. So what I'll do is I'll just break this ideal time into two things here. So I'll put up overall 4 to 5 minutes, not overall, but then for the last three questions. So question number 26, 27, and 28. So typically you should have these three questions done within 4 to 5 minutes. Uh, Additionally, if you have, like, let's say for a particular situation, I'll explain this. Suppose you have visited this set at the first scan itself, and then you have spent 4 to 5 minutes and you decided properly. You have a fair bit of understanding of time management and everything, so you have decided properly and you have spent 4 to 5 minutes on the three questions, 26, 27, 28, and did not do the 25 at that point. That is fine. That is a good decision actually, because later on, suppose you have a situation where you just finished an large set and there are like 3 4 minutes or 5 minutes left in the clock. Now if you whatever sets are remaining for you to do, you cannot solve an entire LR set now. So suppose all the sets that are remaining to do are all LR set types, so you can't solve anything in 3 4 minutes, right? So if you revisit this question and if you're left at 25 for later on, now you can actually solve it, because I hope you can understand. I mean, this will take some doing. I mean, at least 2 minutes it will take. So it will take something around 2 to 3 minutes or something. to solve alone this question number 25, because you have to individually figure out. I tried it from the higher numbers and then came down to the lower numbers. But then even with that, it took around 2 to 2.5 minutes. I don't know. You can check the timing from the recording itself, from this video's timing. But it will take some time to do. So this particular set, I would break down in this way for the ideal time part. But it was a very easy set. There's nothing too much into it. So let's stop this analysis now. And I hope you enjoyed this particular solution. Thank you.